It's always, Power BI, everyone knows it's a visualization tool, very good reporting tool. Everyone knows Power BI. So the exercise we are doing is how to use our language in Power BI, our language in Power BI. And then after that, can I do some visualizations? So that's what we are going to do. So in Power BI, you have many visualizations, right? You can use whatever available visualization, but there are cases where you want to use your own R script because you have done a so good work and very custom programming. And if you want to bring that thing to the Power BI, it is quite possible. But there are a couple of conditions. Condition is one, that you have installed R language. That's the very important part. You have installed R language. And condition number two, that you have installed R Studio. So that is we have already. And condition number three, you have installed Power BI. As long as you have all those things there, should work. I do not have other setup. So you are going to confirm that it works for you or not. It is possible it might have Java or other requirement, just like last time I saw we had an issue. So we'll do that. So I'll do two-step exercise. One, using R, I'm going to bring data in Power BI. Remember, Power BI has a lots of data connections. You can get data from what you call Excel, from MySQL, Oracle, or you can get data from web. Same thing, just like R reads data from file or from web, you can read that data and convert data frame. And whatever data frame you convert, that will become a table for Power BI. And then you use it. It's quite similar thing. One or two line and you are good to go. So R can pull the data, and then bring the data to Power BI. So that's the first step we'll do. Once we do that, we are also going to use R script to create a visualizations. R script to create a visualizations. How to create our custom visualizations? Again, I'll try to keep it simple because once you know that, you just improvise your R script to make your visualization much better. So I'm going to show you those. So it will be fun. Let me know, are you ready? Okay, because this exercise require make sure series of steps are done. So if you are not what you call listening, or you're not able to join our session, then you will not be able to do the lab. Step 1, step 2, step 3. So let's start the Power BI. So we will start the Power BI. So I have Power BI installed. So I'm going to start the Power BI desktop. So if you have Power BI installed, great. If not, you can watch that. Those who have not studied Power BI will study Power BI in coming class, so don't worry about that. So we are right now starting Power BI. Please understand, Power BI is one of the most popular software. It is, designed by Microsoft. It is one of the most popular tool for reporting or visualizations. However, it comes with a lot of goodies. And one of the goodies we are going to add is how to integrate R script in Power BI. So once you start your Power BI, if you get something like this, just cancel it, cancel it. So you will be having Power BI desktop. I'm hoping all of you have something like this. Now, normally when you are doing any analysis, you need a data. So for that, I have script written in our forum. So we'll go to our forum, and in forum, if you scroll down till I'll show you. Scroll down. We completed this, and we are going to, yes, here, run R script in Power BI. So please do come here. Installation perspective, as I mentioned before, you need R script and you need R Studio, which we have everything. Now what we are going to do, we are going to follow the steps. First, we're going to click on get data. Second, we're going to search other. And third, we're going to select R script. So we'll go to Power BI, get data, other, R script. When we click our script, it's going to give a window. And in this window, we are going to read a file from internet. And then we'll create a data frame. And that's it, we'll do OK. So when we do OK, this data frame will come to Power BI as a table. And in data frame, whatever the columns you have, those columns will be visible as a field here. So that's the step number one, how to get data using R script. So if you scroll down, I say, if you click on R script, you will see something like this. And inside we're going to write R script. So I have created a small R script here that this is the website. We're going to read that and create a data frame. And this data frame we are going to bring to the table. So we just need to copy these two lines. Just copy this two line. Make sure you copy this two line. This is the file where we have data. R is going to read it, create a data frame. And this data frame will inject into Power BI. So once we do that, your data frame will be visible. So if you don't want to write DF, if you want a table name, you can change this name to table, whatever table you want, and that table will be visible. And these are your columns. In this data frame, we have three column groups, norm and variable. So I copy this thing. Now I'm going to Power BI and I'm clicking on a get data. Click on a get data. So when I click on get data, I will get a dialog box, and in dialog box, we are going to write R or other. So let it come. Normally it should be fast. Okay, here you go. Now you can click on other. Murthy, I'm able to speak. You may want to rejoin, or you have to have. It seems like it your internet issue. Rejoin. Others are able to hear. You guys are able to hear me, right?
Yes.
Yeah, sounds good, Tushar.
Okay, perfect. Thank you. So click on other. In other, you will see there is a script here. So we're going to click on R script. So we're going to click on R script. So when you click on R script and if you say connect, it will open the dialog box. So I'm going to connect. So it will open the dialog box. And in dialog box, we're going to write the script. That's all you need because it's a data. You can read this file from Excel. You can read this file from database. You can read from file from various sources. You can write some program and get the data frame. Choice is ours. It's our choice. Whatever you want to write R related commands, you can write here. You can create a vector, create a vector, and then you can create data frame. At the end of the day, you need data frame. Either you read it or build it, doesn't matter. So here is that the script will run with the following installation. So it's already there. If you have not installed this, it will not work. Sometimes people have trouble open this thing. So I'll show you how to configure that. So right now, if you are able to do this thing and if you can OK and everything works, your machine is well set up. But in case if it is not there, there are ways you can configure. I'll show you how to configure also. So right now, everything looks good. I'm going to do OK. It takes a minute or two. And on the right side, you will see the fields from the data frame. You will see that in a few minutes. So if
Tushar, I think I lost. I could not hear you, and it's frozen. I could not lost an important step. I think how to load R.
No, you don't have to do anything. I just copied this. That's all I did. Did you copy or no?
No.
So
So
please do so.
Copy and paste where?
Yeah, I'll show you. Did you copy first of all?
One second. Okay.
Then I'll show you quickly. In Power BI, go to Get Data.
Okay.
Okay. And then click on more or other. Let's first just click on Get Data. Just click on Get Data. So it will open the dialog box. Click on Get Data straight. So it will open the dialog box.
Yeah. Okay.
Then click on Other,
Okay.
and click on R script. And then connect. Right?
Yeah.
And then you will have the dialog box. You just paste it. That's all we were discussing.
Okay. And click OK.
Yeah, perfect. And now it will show up here. Now, please pay attention, guys. When you see here data, it will take a little time and you will see tables and everything. And you have to first click here, my mistake. You have to click here, DF, because if you visualize, you need to visualize this is navigator. First navigator will ask you to check this thing. Once you check, you can see all the data, columns and all. If you want to massage the data, you can go to this one and do Power BI query, or straight go to load. We are going to load because everything looks good. So we're going to click on load. When I click on load, it will go to Power BI. So when I click on load, now it will take a minute or two and you will see the data will be visible. Give me thumbs up if you are able to see DF and its column. It is making call to internet. It is downloading the data. So now data is in Power BI memory. And I can expand and I can see 3 columns. Give me thumbs up or say something that yes, I see that. Everyone is able to see? If yes, then you know the first step, how to get data to Power BI using R script. You don't have to just read it. You can process the data. You can create, like example we were talking about. Let's say if you are doing something interesting, that's example here. In this example, we were creating vector, and from vector you can create a data frame also, and then you can import it. So there are many ways you can do. If you are reading Excel file, you can do that also. You can read Excel file, right? And then you do massage and you can create a prediction type of data frame. You can do any middle data frame, you can bring it also. So you can write multiple lines, you can install the library and you can do that also. So there are tons of options you have, bring the data to R. But that's the first step. If you are able to do that, it's a 50% problem is solved. Sometimes people have a little bit difficulty to configure. So there is options available. Power BI has an option called File and Options. So go to Files and Options and Setting. Options and Setting. And if I go to Options, it does give you options to configure R. It does give you option to configure R. So when you see the window, you will see the configure R script, where you can see by default it is configured R and R Studio. If it is not configured, you will get an error. So this is like a Power BI has options setting, and you can check that everything is there or not. Good. Now I don't have to do anything. I'm just going to do cancel. So I have now data through R. Now I need to do visualization through R. So in order to do so, you select the R icon and drag and drop. So you select the R icon and you drag and drop. So when you drag and drop, it will ask you, do you want to enable the script? Just say yes. So please understand, you drag and drop and it may ask you, hey, you want to enable the script? And when you say enable, you will see something here. So you just say enable. So you get that. You say R script editor. It's a gray color right now, but you will see that. Now the reason the editor only triggers when you start using some of the column here. So if you read my forum, I have step-by-step informations. that drag our script visual on page, which we drag, and then drag and drop columns on our visual. So you can drag and drop columns. So I'm going to drag and drop all 3 columns and following scripts. So let's do that. So if I'm here, I can say drag groups. As soon as I drag, the script will become editable. Check it out. I drag it, script become editable. I drag another column, script has 2 columns now. I drag another column and script has 3 columns. So what's happening here, this script has the visual, and then you added all column. So through all column, you enter into script. So this script has now data sets. So this data sets knows how to read this data. So this data set has all 3 columns. So if I say data set, and if I say dollar group, then it has a column. If I say data set dollar norm, that's another column. And if I say data set dollar variable, and I can start writing my program here. And then once I do complete it, I just need to run it. So when I run this thing, I can see visual here. So far, so good. Any questions? Good. Now I'll go back to my forum, and I have all pre-made the code here. So I'm going to say plot. I'm using visual plot. Data set is this, and I'm saying I want to use variable column, color red, and this. I want to do so. So if I copy this, this is the only line I'm copying. You can also copy and paste it here. So when I paste it here, please understand, I didn't type, I paste it here because I know the data sets, I know my column, and you can write whatever you want. So right now, I have this script ready, which is my R script. I'm going to click on play. As soon as I click on play, you will see the visual will update. So if I click on play, visual will update, and you will see nicely the red color because I selected. If I double click here and I say blue, right? And if I play here, you will see the, oops, sorry, my mistake. What did I do? Okay, I need to do play. So if I do play, it's blue shows up. And if I want to write any special command, like example type, example B, or anything which I'm writing, and if I do play, if it's proper, it will make the visual appropriate. It means any R related thing you can write. This is an example demonstration only, but you can write any R related thing and it will visible. Because you are getting column here, it's all column. Without data set, nothing will happen. So the rule number 1, first get a data set, then get all column. Once you get a column, play around the column, and then you do visuals, and your visuals is ready. Once you are done with that, you just click outside and you're perfect. If you want to edit something, just double click on it and you have this thing. If you click outside, your visual is ready, right? Your visual is ready. So this visual, no one knows that this visual is coming from your R program. While this visual is ready, you can use other visual also. Like example, if I want to do donut chart, in the donut chart, I can also do drag and drop group and drag and drop variable. Same like table, this data is accessible for other existing visual also. So there is no difference between this data frame and normal data table. So this is your table. These are your column. You can use any of the visual, or you can use your custom R to create the script. Questions, concerns, doubt? Murthy, so far so good?
Yeah. After clicking outside, how did you go back to that R script?
Double
How can I
click.
see?
Double click if you want to.
Where?
You see my screen? Are you seeing my screen?
Yeah.
Yes, just double click on the graph.
Oh, okay.
So if you double click, it will open the editor. Any other questions? You see how easy it is? You should write in your resume that you know how to integrate R script with the Power BI because, yes, Dave.
So, what is the use? I know you can utilize the Power BI, but what is the main purpose using both? Because you can do same thing in a Power BI, I mean, on our program, right?
Can you do decision tree here?
No. Okay.
Say yes or no.
We got more options.
You can
More
do
function.
extremely valuable thing.
Yes.
Extremely
Makes sense.
complex, very complex thing. This is like a cookie cutter, right?
Yes.
But what you are going to do is very specialized thing. And that specialized things only you can do through R or Python. And that specialized thing only possible when you write a script. And that is the thing you are bringing. You can use cookie cutter, nothing wrong in that. But those are for basic activity. For advanced activity, you need to do programming. So that's the main reason you do that. Makes sense?
Okay. Very powerful.
Very powerful, to be honest with you. See, I always tell people every tool has a limitations, either Power BI or Tableau, doesn't matter. But as soon as you know how to integrate programming language and customize, you have enhanced the capacity. Instead, you extended the capacity of the tool. And this is the reason people expect you to know such kind of programming language, because average person will not know anything, but you know now. Now, if I want to do any advanced related thing, just an example, I have this. Now I want to create another visual. Check it out. I'm just giving you an example. So I pick again R, right? I put it here, click here, again R, right? And same thing, I put the graph, I put the norm here, right? I put the variable here. Now I have script ready, right? I can go in my script ready. So here I can now, let's say if I want to do pie chart, just an example, or you want to do an algorithm, you can do that, anything you want to do. And this is your own script, which is very simple because you have written already, you automated already, you are also giving them options. So you can write that again, whole process I explained how to get the data and how to write the script. Here, any library, if you want to install, you install library in RStudio. Here you just do library. So you just use library. So when you are coming here, let's say example, you are doing any algorithm or anything you're doing, you just use things here. Yes, Christian, any question?
That was my question. Is a full environment, could you install your libraries and things? But you just answered it. Thank you.
Yeah, in RStudio, you can install the library, you can use here. So we'll do that in a few seconds, so you will understand. Good. Now, I want to show you something called QQ-plot. Then we'll jump into another example. So this exercise ends here once we do visualization, but I'm going to do QQ-plot and I'll show you how it works. Okay, so let's scroll up a little bit. Let's do this one. This is you will see why it's power of this. So this is called Pareto chart. Now you come here and you do not have direct Pareto chart available here. Okay, you do not have directly Pareto chart available. So first of all, what is Pareto chart? So Pareto chart, it's kind of like this is the bar graph. So bar graph like that, right? Now this is the bar graph. There is another thing called histograph. Histograph and bar graph. Bar graph shows all point. Histograph use range and create the range 0 to 5, a range, and it doesn't show in between, while bar graph shows everything. Histograph take this range and show like a limited graph because it's called breaks. So break 1, break 2, break 3. And inside, whatever you have, like bar graph shows each graph, but a histograph will show the range. Inside this range, 0 to 5, how many data you got, which is called frequency. Now, histograph has one problem because it shows like this range, right? Now, Pareto chart, what it does, it pick the highest value, which is the frequency wise, and pick the first. So it will say this value 5 to 10 or any category. This is the frequency is this. So this is the frequency, highest frequency, then second highest frequency, and third highest frequency. And now you can draw a cumulative graph. Cumulative graph means when you're going to hit 80%. 80% means if you can address these two categories, then you address 80%. So Pareto graph says that first, Pareto graph is kind of histograph, but ordered histograph. So the highest frequency will go up. Pareto says 80-20, 80%, 20%. Means Pareto says that if I focus on first 20% category, then I'm addressing 80% problem. So example, we have a class. In this class, let's assume we have 10 people. Out of 10 people, only 2 people will ask 80% question. Did you notice that? That's the Pareto principle. That 20% students will ask 80% questions. What does it mean? It's a rule. It's a kind of general thumb. So same thing if your customer complains. If you put together as a histograph in order, first 20% category of complaint, if you address that, then you will address 80% customer complaint. So this is like a wonderful thing. In industry, it's very popular Pareto graph. So we'll do first Pareto graph in R script, and then we'll bring that Pareto graph in our Power BI. Okay, so how to do so? So let's go one by one. First, in my forum, I'm hoping you are here. So for Pareto graph, I created my own data frame. I created my own data frame. I have like a B, C, D, E, F. These are my category. And this is my frequency. Means this is, think about the customer complaint. These are different category of complaint. And these are frequency. So I created 2 columns, 1 column frequency and 1 column category, and I created data frame. Once I created that, I installed a package called QCC. It's kind of quality control check. It's mostly people use this for Six Sigma. Six Sigma students use that. So we are using quality package, quality control package. We install and then we load it. Once we load it, we have a function available Pareto chart, and we are using data frame count, which is this column. So we count that and we create a chart. Because this is the frequency, it will help me to create the chart. And then we draw Pareto chart, like with the little details about main, heading, and colors, heat colors with the length of count. So let's do step by step. So why don't you copy this portion up to this, copy this, Control C, copy this. Please copy this. So this is your data frame. We'll install the package. We'll do the library. We have to do everything. So copy this. And let's go to RStudio. And we'll add somewhere in here somewhere. Let's add somewhere. Create some space and add that. So first we're going to create data frames, which I think very simple nowadays because we have done quite a lot data frames. So DF, and this is the data frame ready. So you can see here category, frequency, category, frequency, category, frequency. Now install quality control check. So install the package. So it's going to take a little time. It will install. Now you are loading that graph. So quality control chart ready, install. Now you're going to say Pareto, just want to see how it looks. So you can see nicely the graph is visible. It is automatically has frequency, and you can see that if I address like this category up to this, then you're almost hitting 80%. So first few category, if you address this category, then you're going to get 80% value, and rest of the category will take a lot more time to get 20%. So if you can fix first high priority category, you're good. So that's what it is saying. By default, Pareto graph looks pretty good too. It has a community graph. This is called community graph, means nothing but you take this item, you take this item, and then plus if you do this height, so if you do plus this height, then you get this community graph. And you do plus this height, so which is like this, so you get this height. So when you are doing that, it's community. So like example, this one was 100 and this one was around 50, then it's 160 here. Make sense? So it's keep adding the total of this, then total of this, then total of this, and that's a community graph. So in order for us to hit, if we can address this, we get 80% of the value. Now, if I do this thing, this is the default implementation. But if I do df count, same thing, give a heading and color, I use a heat colors, means the highest category will have a dark color, lowest category have lighter color. So heat colors, length, def count, which is the same column, means it will give a shading, color shading. So now if I run this command, you will see color shading like that. So this is the top notch category, second top notch, and it can see shading here. I don't have to run this column because this is just a entry of the value. So I'm going to remove this. I don't need to do that. So if I run now everything like this, I get this thing, right? Now install thing I don't have to do. So I'm going to keep install outside. Now, if I run again everything, right? You can see nicely, I can see graph. So far, any questions? So far, so good. Now I'm going to try to do this thing in a Power BI, just to give an idea how to bring this type of beautiful quality graphs in thing. It is also possible this data you're reading from web or reading from file, and then you are doing a lot of massage, you are applying your filter, you do a lot of things, and then you will bring it. So right now, first thing I'm going to create data frame here. Okay. And I'll say complaint, right? Just say complaint. Let me make a meaningful thing, complaint, right? And here I'll say count. It's a complaint count. And this is like a category. I'll say category. Okay. So here it's a count is count. This is fine. Everything fine. Complaint is complaint. So data frame is complaint. And instead of this, say complaint, complaint, and complaint. Oops. Complaint. So now if I run this, I just want to make sure everything works fine. Perfect. So everything looks good. Now I want to create this data frame in Power BI. So what should I do? I have to click on Power BI. Then I need to go to get data. You can say more, or you just click on the get data here, straightforward. You click here, get data. It will give you dialog box. And here in other, click on other, and you have R script, other R script, and you just click on connect and you paste this one. So you can see here, I'm creating this data frame with my custom column, category and count, and the complaint data frame is created. Now I have to say okay, and that data frame is now visible. And you can see if I click here, I have two columns, category and count. I'm hoping everyone is doing along with me. Now click on load. Oh, sorry, I did escape. Sorry for that. I shouldn't have done that, but I did escape. So it's close that window. Sorry. Okay, I other and R script connect, and I'll do Control V, and I'm going to say okay. So that is done. Now very soon you will see navigator. I click on that and you can see nice data is there. There is nothing wrong. So click on that. So I say complaint. You got the data. I'll say load. So now I will have a second column here. Good so far? Everyone is good? Okay. Now I'm going to drag this complaint. So here I drag the complaint first here. So category and count sorry, because it's mixed match happened. So let me delete this thing first because it's a prior. So I'm going to delete that and I'll add another R script just for that because it seems like mixed match. So here I put a complaint and now I'm going to say category here and count here. So I added a new R script. I added a new R visual and then drag and drop 2 columns. So you can see that the data set has 2 column category and count. So this is my data sets. Now I cannot change these things because this is what this program will understand. So I have to bring my R script here. So here it used to be complaint, but when I bring this thing, it should be data set. So let's see here. So if I paste it here, you can see here, this is the data sets. So I have 2 choices. I'm going to do this way. Complaint equals to data set. So what will happen? I am copying these data sets to my complaint and then the rest of the things will be going according to mine. So I just added 1 line, right? So whatever data sets we receive, the data set will be known as a complaint and then we are going through this. So if everything is right, I should get my histograph, my Pareto chart here. So I'm going to play it. It may take a second or 2. If everything goes well, we'll see that. And ready, set, go. Say ta-da. Pretty good, Dev. You see how you can bring your custom charts?
Can you go back once after pasting this code?
That's all. You just need to run. You just need to run. I added just 1 line and just run. That's pretty much we need to do. I'm hoping that you drag and drop both column, right? Category and count, right? And then rest of the code, we took it from our Art Studio. We didn't change anything. We just copy data set to complaint. That's 1 line we added. Yes.
Product and count. Am I looking at the wrong one instead of category count? I have product and count.
Yeah. Which one?
It was underneath the Pareto chart, types of medication errors.
Yeah, because when we created data frame, right, we copied this one. That time we have selected a category and count.
Okay.
So you might have not changed it. I changed it. It was a product, right? So I changed that.
Okay, that's what I didn't do. Thank you.
Yeah. So it's whatever heading you want to give, but overall everything under your control because you can change the names if you want to. You can change name categories and you can change also. But are we able to see the Pareto graph after doing this? Murthy, are you able to?
Oh, not yet. So we don't need plot df count, right?
You just please understand, you just copy paste and add this line. Do not try to do something different because these are all validated commands, right? We just validated through RStudio. So we changed naming conventions to make it more meaningful because it used to be DF, right? If it used to be DF, we named proper. So, it makes, because when we do like work, we need to give a proper name to our framework. So we give a proper name. We didn't use DF. We say, it is a complaint. It is a complaint. It is a complaint. Makes sense or no? So it is easy to, because you analyze for certain data. So DF and all will not give a clue what you're talking about. So that's why
I got it now. Yeah, thank you.
Good. So I think that gives enough experience about R with the Power BI. Now, 2 more things and I'm done. Okay. So this Pareto is done. Gentry. Are you guys ready? Say yes, at least. No one is saying yes. At least one person saying yes, right? So decision tree, is very simple. So example, anytime when you make a decision, you have some option to select. So example, I have $10. So here, do I have money? Do I have money? So you're making decision. Answer is no. So I can say stay home. You can say yes. Then you can again make a decision. Is it greater than 5? Answer is no. Then you can say go to McDonald's. Yes. Then you can go to movie. So everything you can make a decision. The first decision define the direction, left versus right. The next block will also decide. So as you make decision, you're traversing. So like when you do think about when you apply for a loan, first of all, are you working? Answer is yes or no. Are you owning house? Yes or no. Are you having this? So basically, more you go, the direction will change based on your yes, no, and then this is your output or outcome. So this entire thing is a decision block, and once I have decision block, if I give it to human can follow that. Are you working? Yes. Are you owning? Yes. Then you are yes, you're approved. Are you working? No. Are you having this house? No. So human can follow this diagram and can approve or disapprove. So example, do you want COVID vaccine? Yes. Are you in A group? No. Are you elderly? No. Are you having any health related issue? Yes. Then you go for this. So most of the time we make decisions, and based on the decisions we are going. Now problem is human normally ask questions. Doctor or nurse, they ask question and then they give you prescription based on your symptoms. Whatever they ask, if I collect 1,000 doctor questions, do you have fever? Are you losing weight? Are you having good night's sleep? Do you have any reactions? Do you take any medicines? Are you happy? Da, 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 da. So those like basic question if 1,000 doctor ask, and based on the tree, we come up with what doctor recommend, which medicine recommend, or what kind of prescription they recommend. If we can create a tree, then after 1,000 patients, if 1,001 patient comes, I don't need doctor. I can go through tree and I can recommend you need this prescription. In that case, I don't need doctor because I have trained my model. This is my model. And my model will be trained based on the data. More data, more training happens. But doctor makes mistake too, because doctor asks question and maybe they might go the wrong path. They will prescribe wrong medicine. Same thing, this model will make mistake as well, because when you make a menu decision, it is possible that you end up here and there is a likelihood, maybe 5%, maybe 10% you are wrong. And that is called error. Doctor makes error too, everyone makes error. So the steps is first you create a model. Second step, you use training data. You do training data. So when you do training data, the model will learn from using training data. Once your training data is done, then you use test data or sample data, and you pass that to the model and see model predict the correct output. Just like a human can predict. There will be error, but if model can predict 85% correct, then you don't need a human. It means you don't have to pay doctor 800,000 salary. Whatever doctor was doing, now this software will do. I can give you guarantee within a year or two, you will have vending machine, just like a red box. You go to Redbox in Walgreen or somewhere, and you go and get the DVD. Same thing, vending machine will be there every store. I can tell you in 1 or 2 years. They will ask, how old are you? What's your weight? Is there any symptoms? Any disease? Any cancer in family? This thing. What are symptoms? Okay, here is the prescription. That will be based on decision tree. If algorithm is there, I can give you guarantee that will give you decision. And this is called supervised learning because this model need training data. This model is trained. Once you train that, then this model will do just like a human does. There is an error, and if you want to improvise the error, every time you make error, you improve, educate your model, so model will become better and better and better and better. And that is the reason Google Car works very well. And that is the reason many places driverless cars are there, because they use this type of model called decision model, when to apply brake, when to speed up, when to take a turn, when to stop, when you go to reverse, when to turn lights on, when to have like horn. All those things are decisions. And Google's cars, just concept car which we heard, they have applied hundreds of thousand data. And car is now at that level. They are saying, not me, they are saying that they make a much better decision than human can make. Because human, when they drive car, every time you drive car, your position is different. Means sometimes you're happy, sometimes you're emotional, sometimes you're unhappy, sometimes morning, sometimes day. So same condition, car has 100,000 data points. So it has a much more data than a normal human being can have. So they are saying this will be more safer car or safer drive than human. That's a decision tree. I have another example. Like example, you got an offer.
Question.
1 second, let me complete.
Okay.
So when you got an offer, so you got this thing. If salary is less than 50,000, if your answer is yes, if commute is 1 hour, yes, the offer decline. If salary at least 50,000, so no, your offer decline. If salary is more than 50,000, commute is less than offer free coffee. If offer free coffee, no, offer decline. And if everything yes, then offer accepted. So here the feature is depend on these conditions: salary, commute, and coffee. So these are, when you collect the data, please understand, when you collect the data has to have those column. Column one will be salary detail, one will be commute detail, one will be coffee detail. And based on the data, accept, decline, accept, decline, accept, decline. So example, salary is 40,000, we know it will be decline. So this model will know if salary is 20,000, without hesitation it will decline. But whenever you make salary let's say 60,000 and coffee is available and commute is less than 1 hour, it will accept the offer. But if something is no, it will say no. So if this model is ready, now next time you ask 3 questions. If salary is 30,000, 32,000, boom, offer decline. If salary is 75,000, next question you will ask, commute less than 1 hour, is now 5 hour, boom, offer decline. So then you don't need a human. The algorithm will make decision, and that algorithm is called decision tree. Yes, Murthy.
Yeah, the first thing is you said about training data and test data, right? I'm not very clear about it. So and second thing,
let me explain first of all. Let me explain. Okay. When doctor go through the training, means college or school, right? Doctor goes to school, right? When they're in school, they are also checking patients, yes or no?
Yeah.
That time they are not really a doctor, but they are under training. So they're learning, yes or no? As per United States law, every new doctor has to go for residency for 3 years. Yes or no?
Yeah.
In 3 years, whoever they see, those are called training data. Make
Okay.
sense?
Okay.
So if training data is less, the doctor learning will be less. Yes or no? It means when they go to real practice, they will make wrong decisions.
Okay.
Make sense?
Okay.
So when I'm in a lab, like example, I have mice and I want to experiment the vaccine. Every time when I experiment, it is a training. Yes or no?
Okay.
Because I'm still applying to mice. But when I apply to human, that's a real test. Do you agree? So algorithm, when it is going for trial, any data you use is called training data. If training data is bad, algorithm will understand bad. If training data is good, algorithm will understand good. In that case, more algorithm understand, algorithm will create a model, and using model, algorithm will make decisions.
Oh.
So you are driving car? Do you drive car?
Yes.
Okay, and you are using cell phone?
But no, not while driving.
No, I understand, but you are using cell phone, Samsung or Apple?
Apple.
Okay, so when you are driving car, Apple is sensing your driving pattern. If you are driving Samsung, Google is sensing your driving pattern. So when you are driving, that's one sample. When I'm driving, that's a two sample. We are not telling, but they are collecting how you're applying brake, what speed you're applying brake. They're collecting. These are 100,000 driver they collect, and then they pass that to their model. That this situation, this driver apply brake. This situation, this driver have taken left turn. This situation, this driver reverse. This situation, the driver turn light on. All this data, they collect driver by driver, 100,000 times they collect. And then they pass to the model. So model understand, okay, whenever this thing happen, driver does this. Whenever this thing happen, driver, after that, model will be very knowledgeable. And then it goes to real practice. And that time you make real decisions.
Okay.
Make sense or no? I'm going to show
Yeah.
you. I'm going to show you in 2 minutes.
Okay.
Are you ready?
And I have one more question
Yeah, go ahead.
about this decision tree. This kind of in most of the projects we will use this kind of decision tree. What is the specialty in R?
How you make the algorithm. How you make decision. You as a human make decision. We are not going to make decision. Our program will make decision. So what is the program? R will make the decision. Can you lifetime you can make decision? Maybe yes, that's called human, and you will become expensive, right? Who will pay $80,000 for making decision when I can do in 10 cents? Yes or no?
Yeah.
I can give you guarantee doctor will not be the high profile profession. Why? Because whatever doctor is making right now, they are training the model. Google is creating a medical, Mayo Clinics creating the medical models. Many models are created. So now basic activity model will do. So you only will go to doctor for certain type of surgery, but cold, cough, certain thing, vending machine. Just like vending machine. Remember, when you want coffee, you go to vending machine. When you want chips, vending machine. But if you want special coffee, you go to Starbucks. Same thing. Same thing will happen. Our programming will give you that supervised learning algorithm. Make sense? That algorithm will replace human. That's why this is called machine learning.
Okay.
Right? This is scary, by the way. More and more it's coming. Right? In your house, if you are having like a what we call iRobot or whatever they call, the cleaning the floor, it use decision tree. It does much cleaning than you can do, right? Because it does use decision tree. This object is there, so I need to turn this time. If this is there, I need to be this distance. I need to do so that automatically learning. So once it learns, it becomes much more talented. Okay. So R and Python programming is used for automations.
Thank you.
Okay. No problem. Now, for this exercise, I will explain here and then we'll do the exercise. For this, I'm going to create a data file, which I already have prepared for you. Please relax and understand the data file I have here in my local machine. I created already data file, see salary. Yeah, here you go. I want you to see first, understand that I created a training data. So this is the training data I created. It takes me a lot more time to do all those things to generate this thing so you can easily understand. So I have employee, I have employee name, I have employee salary, and I have employee role. Very simple, easy data, because no matter what you look for outside, this decision tree algorithm is so complex where you cannot easily explain in this kind of classroom, because they expect you know a lot more thing in math and all. So I create a simple practical example. And everyone can see the data. It's human nature, readable data. Now, what we are saying is, please pay attention so you would really appreciate this algorithm. What we are saying that the roles are there. So manager is one role, supervisor is another role, and analyst. I use only 3 roles, but I can use 4 roles also, 5, 6, 7 role, I can use it. Now, what we are saying that this role has something depend on the salary. So I'm tightly coupling on salary, but you can add many column also. You can add a salary, you can have a commute, you can add other thing, but I added only salary. Now, what I'm saying here, please understand, I'm saying that if I know salary for around 70 to 80 employee, listen carefully. If I know salary, based on the salary, certain confidence, I can tell you your title. Certain confidence, I can tell you your title. So example, here 2,700. So I say analyst, 2,300 analyst. So it appears if salary is less than 3,000, most likely you will be analyst. Makes sense or not? So I'm educating my algorithm. So if I give salary 1,000, it will automatically say you will be analyst. And then it will give some percentage. What percentage I will be accurate. There will be error. Don't take me wrong. Algorithm always have some error, but 80% you're right is much better, right? Than I hire 80,000 salary person, right? So we can improvise algorithm based on good data, but it will make. Then another way to see is this algorithm will read that anytime 3,000, it looks like your manager, but here 4,000, here 5,000, good. Oh, this is a problem, means something happened here, maybe error, here fine, here fine. So it kind of create a model that maybe around 3,000 above salary, most likely you will be manager. And same thing it will do for supervisor. So we are taking this data as a training data. We are taking this data as a training data, and then we are going to give to algorithm. This algorithm will generate a model. This model will say, draw this model. So it will draw the decision tree. It will draw the decision tree. Once a decision tree model is generated, we say, okay, from this data, let me do sample data. And then say, hey, model, use this sample data and predict. And let's say if I use first five data and predict. So it's going to predict, and it will most likely be going to predict very similar to this. It might have error, but it will predict very accurately. And when it predict, there will be a percentage of confidence about the predictions. So we'll learn that. So first we'll take this data, and from this data, we can say 75% data will take as a sample. This is total data is called 100, suppose. So from there, we are using 75% data as a training data, and 25% data we use as a test data. Again, you don't have to do this, just an example I'm using because I have limited data. So I'm from 75%, I'll use this data to algorithm. Algorithm will generate a model and then we'll say plot this model. So it will plot decision thing. You can visually see that. And then we'll use 25%, which is called test data. And we'll say use the test data with the model and predict. And when you predict, what kind of things it is predicting will validate. If it is close to right, then model is good. If it is not close to right, there are two problems. One, training data is not good. If there is a bad data, the model is bad. And if model is bad, prediction is bad. So you have to continuously evolve this training data to increase the model because this algorithm is smart. There is nothing to do with the algorithm. Algorithm is there for, very after a lot of verification. These are all, approved algorithm. Means people have received a gold star and something like that because these are very good algorithms. So the algorithm doesn't have problem. If you have wrong data, algorithm will learn wrong and predict wrong. Good data, algorithm will prepare good and predict right result. Now you say, how do I know good data? Human nature. So you have to have knowledge. That's why this is called supervised learning. Supervised learning means the person who is doing this activity is experiment person who is doing researcher. That person should know the real life. So example, if I have a car data, if I'm driving car and if I have car data, so car, when I buy a brand new car, and if I collect the data, brand new car, that's called good data. Because when you have car good, it has a good mileage and all. So if I train with the good data, and then if any new car, if I take as a sample, it can predict good. But let's assume I use car with a 25 or 30 years old car and collect the data and use this model. And then I use new car and try to use, it won't work because the old car behavior is quite different than new car. So that's why this is called supervised learning. Human makes a decision here. Good data, bad data, good data, bad data, and train the model. If you remove the human, this algorithm will not work well because bad data or good data, who will make difference? This algorithm itself does not make difference. That's why this is called supervised learning. You have to train this model. Once you train the model will make the decisions. Questions?
This data is okay, but if there are some outliers, how do we find it?
That's an error. You don't have to find it. You can find yourself if you want to. That's an error, right? Because example, all car you have, right? All car you have, it is possible some new car also have a bad engine. It is possible. So in that case, human can remove by checking the data. Like example, someone's salary is 0 or someone's salary is minus. You have to do filter. That's the reason we studied filter, right? How to filter the data. Some observation you need to do. This is the research, just like your vaccine you are coming with, right? Vaccine, trial and error, trial and error, trial and error, trial and error. It takes time to train this model. Once you train model, then magic will happen.
Yeah, even after filter, is there any special way in R to find outliers?
R itself doesn't do anything. R itself doesn't do anything. You use R to do that work. R is a language.
Yeah.
R is a language. You use language to write a program. So you have to write small program, which we call analytics. Right? R itself doesn't do anything.
Yeah.
Right?
Okay.
Everyone understand? If I have dictionary, English dictionary doesn't do anything. I create a sentence. I use paragraph. I write essay. But dictionary doesn't do anything. Just like R, it's just dictionary. It has a library. It has a functions. It's a program syntax. But you as a program, that's why you are data analytics. You are getting money because you know R. You're using the R language to do the cleaning and filtering. Right? Rest of people, any other questions, concerns? These are like things you can share in your interview, by the way. This is very, very important. Very limited people know. So feel free, if you are not very clear, ask. Okay. Exercise is going to be very simple. Concept is very important. Okay. Now, I want you to download this file. So you just click here and download this file and copy this file under your C drive data folder. Download this file and copy into your C drive data folder. Let me know when you download and copy. Good. You just download, click here, download it, and put it into C drive data because my program will read that. So now we are going to use this library just like last week we will use this library. So this library can read Excel file, and this is the loading. And there are a couple of library we are going to use here, which will allow in case if I forgot any installation package, we'll do so. So let me start doing up to this. I'm copying this thing up to this. So I'm going to copy this. This one will read the file, the actual employee, and it will generate the data frame. And this one will print the data frame. Okay. So I'm going to copy. See, I'm doing partial program just to give idea how it will work. So now I think I already have installed here, so I shouldn't be okay. It's there, no problem. And I'm going to one by one library should be no problem there. So all library loaded. Now I'm going to run this thing. So it should create a data frame. And here you go. I'm able to see the data frame. So I have all my data available. Makes sense, son? Give me thumbs up if you are able to read the data frame, the Excel file, and you have data frame. Total, we have 58 rows. Good so far? Okay. Now, after I read that, now here we are going to do a decision. We are going to say that our whole decision based on role. So manager, supervisor, right? Analyst. So we are focusing that, and this is the factor. Factor means we want a decision factor. So we want to factor this thing. So we are converting this sum column to factor. So we have three factor: manager, supervisor, and analyst. So it will do that. Now, please understand. Now we are saying role, which is this one. This is the role versus salary. So based on the salary, we want to predict the role. So it will create a tree, and data is our same data frame. Once I create the data frame, I want to plot it. So let's do up to this level. So you will really understand how it works. To this level. So check it out. First, I'm going to create the factor role as a factor. Role is the column. So this role, this is a normal column. I'm going to create a factor. So if I do that, it will create a factor. And then I'm using this command to create a tree, decision tree. This is the algorithm. So if I run this, it creates a tree. And if I click on the plot, it will draw a nice tree here. Give me thumbs up if you're able to see this thing. I'm not able to see thumbs up, so I'm assuming you are, if you can speak up, yes, no. So at least I know. No one even speaking that, huh? No thumbs up, no talk. How do I know that you're doing or not?
Yeah, we can see it.
Thank you, Silas. It's pretty awkward, right? No noise, no thumbs up, no reaction. How would I know that you're doing or not? So this is like one of the important lab. I'm hoping you can confirm, at least some of you can at least confirm that it's working or not.
Yes, it's working for me.
It's okay to say, guys, because remember, when you are working remotely, if you don't acknowledge, there are three reasons. One, you are not there. Second, you're not interested. And third, you don't understand. So please acknowledge that, make habit, right? I work all the time remotely, camera on, talking, thumbs up, reaction, so much tools available. Okay, I'm hoping you are able to do. Now
To
let's
me, I think I have some glitch. Sometimes my program is not working. Right now, it is not. So far, it's worked. Now it is not working again.
It's a copy paste issue. So maybe you can try again step by step.
Okay.
Make sure you have this thing. Okay. If you don't have this, means you already made a mistake. In that case, you have to restart. Okay. If you don't have
Okay.
this,
And this
Mhm.
library party, it is not loading one way. I don't know why.
Which one?
P-A-R-T-Y, party.
Party is not loaded.
Yeah.
So,
It
It was
gave me.
happening with
sorry.
me, so I just installed that party
Yeah.
library.
So you can do that. Very good. Very good. Richie, that's the way I want you to speak up, guy, because otherwise, like a Murthy type of person will not know, hey, how they made it working, right? Because I do this practice many times, so you can install like that. So you can run that and you can install.
Tushar,
Yes.
I had a problem installing Party also, and I dropped something in the chat that I installed that way, and it functions.
Oh, you did that? Awesome. Awesome. Welcome. Good. I'll keep it here handy. Yep. So that's also nice, different way. But I want you to see the graph and try to interpret first so you can understand the model is created, right? Now, what did this model say? How you as a human understand? So we are saying that P stands for probability. P stands for probability. So probability, if it is close to, probability of error, my mistake. If it is close to 0, it's a good thing. If close to 0 is a good thing. So here you can see decision 1, salary. If salary is less than 3,700, then you are going this side. But if your salary is greater than 3,700, you're going here. So they say n equal to 14 means 14 observation, means 14 data went this side. Out of that, manager was almost 80%. So this model will by default, listen carefully, this model will by default, if you say 4,000, most likely it will say manager. Why? Because if you see that comparison wise, these are 3s there, but manager was more often. If you go this side, if the data is 3,700 less, and if your salary is less than 3,000, based on this, 60% chances your title is supposed to be analyst. And 20% chances. So here, if you come this side, most likely the model will predict as an analyst. If your salary is between 3,000 and 3,700, then it will 90% chances will predict supervisor. Wherever the bar is high, it will naturally will predict. You can see there are errors, but significantly higher success rate. So it's going to predict accordingly. So far, so good. Any questions? Good. Sometimes if you do smaller, you will see different graph like that. So it's important that you expand and see that so you get a full graph. Yeah. Now my model is ready. This is my model tree. Now I want to use some sample data. So see here, we are saying use this model and predict first 5 data from my data sets. So from my data set, take 5 or 6 data and predict to see how closely it predicts. So this one is taking this model which you created, passing this model and say predict head 5 means take the 5 row and predict. So when it predict, the prediction we will see that is here. So what it is predicting, let's see here. So I'm copying this and I'm pasting here. So first I'm gonna run this thing with the 5 record, it will predict first 5 record, and then I'm saying print the prediction. So you can see that it predicted manager first, analyst, supervisor, and analyst. Okay, manager, analyst, supervisor, and analyst. So if I go here, it is possible it might have done right or wrong. So let's see how much accurately it presented. So here you can see first is the manager. So manager, analyst, that's wrong. Analyst, that's right. Supervisor, that's right. And manager, that's wrong. So quite 30 to 60% success rate with this thing. Now, if I do more, the data has to be good. So you can see this algorithm has a 60% success rate. Now let's say I want to do reverse. I do tail instead of head. Let's say tail. Maybe model might be understanding better later on. So run it. And then I predict. Now it says supervisor, analyst, manager, analyst. So now if I go to my data, this is the data and see what is it does. So here you have, so first of all, we are having how many? 1, 2, 3, 4, 5. So the last one is analyst. So that's wrong. Then this is analyst. That's right. This is manager. This is right. Analyst. This is right. Supervisor. It is right. So here 80% chances it generated the model. So this way you can continuously use data where your percentage chance increase. When you are able to come like 80 to 90%, then model is good. Then you use that model in order to make decisions for outlier. So any time when you do programming, you get a data, but sometimes, most of the data are here. But sometimes your data will be like this. Your 99% data is here. But there are some data are here. And this is called outlier. So example, right now we have around 18 students in the class. If I ask how much you make, so average person will say 100,000. Someone will say 105,000, right? Someone will say 99,000. Someone will say 110,000. Someone will say $5. Someone will say 5,000, 500,000. So you can see right now this value and this value is outlier. These values are kind of close. So the question is, how do I find outlier and I can remove the outlier? That's the exercise we are going to do. Why? Because if you consider outlier in this data, then your analysis will not be good, because $5 salary will create a mess in this average, and 500 is also because these are odd people. Maybe it's a data error, maybe something abnormal, but if we keep that good data like this and analyze, then most likely we'll be right. But if you use all data, you will have more error because this data doesn't have some similarity. So how do we find outlier and we remove outlier? That's what we're gonna cover that. Now, in order to do outlier findings, there is a nice plot. It's called box plot. Box plot is available. So box plot goes through like this way. So you have minimum value, you have maximum value. Then you have plot like this way. This is called box. And this one is your first quartile. Then you have second line, which is the second quartile. Then you have third line, which is the third quartile. Easy language. If you draw like this, right? This is your first quartile. This is your third quartile. And if I draw this one properly, it will look like a box plot. This is your minimum value. This is your maximum value. So if you draw this thing, you can see now it's a box plot. So box plot look like vertical and this distribution look horizontal, but concept is same. So here your minimum, here your maximum, here your third quartile, here your first quartile, and this is your average. Now, if you see this couple of dots, they are outlier. So box plot can easily find out outlier because they have some function called outlier. It can find out. So we have to understand how to do this exercise. So the question is, how does it find out outlier? So there is a special mathematical formula, which I will be trying my best to explain. So if you pay attention, you can understand. In interview, people might ask you depend on your deeper understanding. We call double click. They will go to deeper. So this is your third quartile. This is your first quartile. And in between this is called interquartile range. Interquartile range. So this is the range. Now, the definition of good data is if this is your minimum, this is your maximum, just an example, then you take this first quartile, whatever value you have. So this is like the first quartile. You do minus 1.5 times IQR, interquartile range, which is the length of this. Now, why 1.5? Don't ask me. This is the algorithm. First quartile will define automatically based on the data. IQR will be defined based on data. So if you do this, it will automatically give you 1 point here. And if you do the same thing, like example, third quartile, but instead of minus, you do plus 1.5 times IQR. And if you do so, you will get somewhere point like this. So you draw a line, anything after is outlier, anything before is outlier. And this is the way it automatically calculates that. You don't have to do anything. I'm just explaining, it will automatically find that because it follow the algorithm, how many data is not following proper, and it will calculate as an outlier. This is already built in a box plot. Any questions so far? Okay. So let's start. All the explanation I have added here in case if you want to read. So for this, we copy here. We'll copy everything. So just we can easily run that. So we'll go here, copy RStudio, and we'll put it here. And let's understand step by step. So I added here. Okay. Now for this, we need to install ggplot. So why did I not install ggplot? Where is the install ggplot? I think it's a previous lab I have added ggplot. So I want to make sure we all have ggplot. I'll put it in a chat. This one, because we do need a ggplot. Sorry for that. I'll put it in a chat. So you have that instructions how to install ggplot. So I'll put it here. You can see I'm installing ggplot. So this is very, very popular chart in R programming. Many times people will ask, do you know ggplot? It has a lot of feature. You will love it if you follow that. So if you click here and if you run it, it will install. Though I have installed it, so I don't have to worry about it. Install package ggplot. Then I'm going to do library. Now it does come with some data, which is called mpg, miles per gallon. So I can click here, and if I run that, it does generate the data. And if I do summary for highway, you can see that it creates the summary. you can see here first quartile, you can see here third quartile. So if you do the difference between this, it will be around 9. That's your IQR. So IQR is here. Now if you multiply IQR with 1.5, so if you do 1.9, it's almost 13. So if you go this side, it's a 5. And if you go this side, it's 1.5 times the 13 plus this, so almost 40. So 40 will be your highest limit. Anything above 40, it's outlier. And anything below 5, it's outlier. And it will calculate that. So it does that automatically for you. So far we got the summary. Now we want to see, is there an outlier? Is there any outlier? So we're going to go back and plot that box plot. So we'll see that. So I'm going to plot this box plot. So here, let's do histo first. So we'll see that. So first I'll copy histo and run it. So I already have copied. Very good. So I'm going to run this histograph, and you can see that in this data, it's clearly this is outlier. Why? Because here is the max you can have. So this is the outlier. Histograph clearly show that this data is far from the normal data. This is the hist is the default function. Hist is the default function in R. But if you go here, there's a ggplot, which is much smarter and interesting. So if you can click like that, highlight and run, it will give you much better graph like that. So you can see box plot, ggplot, and you can see the dot. These are outlier. It's visible. Now, if I run this thing, box plot, I can also see the same in a box plot too. This is normal, and the other one is the ggplot. These 2 points are definitely outlier. Now, in order to get the outlier, box plot has a function called statistics. The column which we are using for box plot and out, which is the outlier, will be now going to the vector out. And we can print it. What are the value we get as an outlier? What is this value? We are going to print it. So highlight this too and run it. So when you run it, you can see that it says there are 3 values, 44, 44, and 41. These 3 values are not inside. It means they are outlier. Now we want to remove this thing. So how do we remove? So there is a command called which. There is a command called which. There is the original data, and this is the outlier which you want to remove. So you're saying that find outlier rows. So first, this is the original data. You're using in operator and this. So it will find out where this data exists. And then we will say not, remove this one. That's what we're going to say. So check it out. First, we are saying run this thing where this outlier 44, 44, 41 is exists. So you can see it will give an index, outlier index. So it's at 213, 2022, and these are the position. Then we are saying that remove that. So this is the way. So you can see when you use not, it means this is the original data. This is the outlier data. You're saying this data, remove it from the original. So this one will remove the outlier. So if you do that, now your new data, if you click on that, highlight and run, it will now remove the data. Now, if I do box plot, you will not see this dot, and you have successfully removed the outlier. Sorry, you highlight and you successfully remove the outlier. Now you can analyze. Question, concerns, doubt. Good. So please, in your data, check that is there any outlier. And if yes, remove that. If you don't remove, your analysis will be incorrect. Your project is due next week, and I'm hoping that you will do a lot more work. In this class, I have added so much forum in the Google, in our Infotech. If you just practice few times, and I can give you guarantee, if you stand in interview with this knowledge, you will be selected. But you need to know in and out what we have added in the forum. Make sure you know in and out. Few days practice will make you master, and that's why we give you project. And I'm hoping you're working with the group. Two more things quickly I'll walk you through.
Question. Is here we got 213, 222, and 223. Those are row numbers in.
Those row number in the data frame. So
Okay.
which row it is, and then it removes that row. Basically, when you do exclamation, it removes that.
Okay. Thank you.
No problem. Now, this is another data mining techniques which we talk about called regression. But this time I'm going to use regression with, QQ plot or ggplot. I'm going to use with ggplot. So you will see better graph. Okay. Again, you know very well everything. So nothing special. We are going to use data. We're going to use mass data. We're going to library, which we already have. And there is a special package we are going to use the CA tools. Now, using the CA tools, let me first copy that. So let's copy that. Copy. This is a little bit above in outlier. That is the regression, data mining techniques. So I'll put it here and paste it here. And let's do one by one. So first we're going to install data sets. So highlight and run it. So it will get the data set. So you can see mass data set here. You have data, Saturday, inflation, type, count, frequency. Some data is available. So no problem there. We are taking this data right now, library cat tools. Sorry, my mistake. First we'll install this thing, cat tools. It does come with the good data and libraries. So we'll see that. So I'm going to install that cat tools. So it installed that. And then we'll load the cat tools. This allows me to, split the data. Basically, you can split the data and like that. So that category type of thing, you can do that. Now, this will give me the data, which I'm holding called housing data, Boston housing data. So I'm going to create a housing data frame. This will create a data frame. So run that. Now we are saying that from housing, split ratio 75. So if 75 means there will be a true for 75 and false for 25. So if it is true, that's a 75% because you say split ratio 75 means 75 data will have true, 25 data will have false. So 75, wherever is true, we can say training data. And 25, where we have false, we'll say test data. So let's see here. So first we're going to run here. So the original data was housing is now divided into two sets, training and test data. Training data we'll use for model. So we run this and this will create a training data. And if we run this, it will create a test data. Now check it out. The training data we are using for regression modeling. So we are using LM. LM means linear model. We have median. We are comparing. We are taking this data. We're comparing this vector with dot means all vector, and you're creating a model. You're creating a model. So check it out. We run this thing and we'll have a model. So we use training data, which is 75% of our data, and now we have model. Now model is created. So if I draw the graph, model will have something like this, right? And I can draw a line, it will be like this. Now I'm saying, hey, I have 25% test data. If I use this test data and use the model which I created, so model I created here, if I use this model and you use the training data, so test data, sorry. And if I predict how it will look like, if the prediction is coming closer, then my prediction is good. But if my prediction is coming far, then something wrong. So we are trying to do that. So now we are predicting 25% data. So we got that. Now we are going to plot this thing with ggplot, see how it works. So I'm running it and I'm presenting. So you can see now it's going to take light time, but you can see beautiful graph. So what did we do? How it works? So first we are using here predicted this thing. So this is the predicted data. Your y-axis for predicted, and your x-axis, which is the driver, which is your original column. So you can see here we predicted data with the model. So you can see a data equal to test. So you did test geometric point. Geometric point means the line, circle, or cylinder. These are kind of different type of geometry you have. So you can see here we have a nice cone here, so here, right? That's called smoothing. So you can see a geo point alpha 0.5 color blue. So you can see that this is color blue, and because you have alpha 0.5, that type of color, it will adjust that. So you can see color. Scale y, continuous y, which is nothing but this y, and the other is this. Now you can see geo smooth, because this is the cone, geo smooth, this smooth. Status equal to smooth, color equal to red, which you have red in the middle, and method equal to, we are using this one, linear regression. So what you are saying here, if you predict, this is your model, if you are close to this line, then your prediction is pretty good. But if you are too far, then this is the wrong prediction. If you are closer to this is all good prediction. But this is bad prediction. So you can visualize your prediction. It means your model require rework. The best way to do is check the correlation. If correlation is greater than 0.95, you can predict better. But here, looking the data, look like correlation is not that great, because some data is far from the line. You can see that these data very far from the line. So these are bad prediction. It means your correlation is not good. So you can see the QQ plot helps you to do nice, beautiful graphs and charts also. Questions? Question, concerns, doubt?
So one thing you said, training data 75% and test data 25%. Is it a test of hypothesis?
Yeah, it's basically, you are having, you're preparing model, right? So you can say, you know what, I'm going to prepare model with this much data. When models is prepared, I'm going to pass this data to see if model is working or not. Now, you can also have like separate sets of data for model treatment and separate sets of data for model validation. Instead of that, we are using the existing data and dividing 75% and 25%. Can I do 80-20? Yeah, it's our choice. Can I do 90-10? Yeah, it's our choice. If you do that, it's perfectly fine. So we are using same data for training and testing. So testing data, we are keeping 25%.
Okay. Thank you.
Any other questions? Good. So, spend some time, guys, because I know we are almost on time. I really want a good project presentation, because you saw how much detail we have covered. A lot more. I can tell you, even the people who are taking like, master degree in data analysis, they don't go this much detail. That's much content we have covered. Now choices is next week, how you and your group is presenting. Project details are all documented nicely in our Google Class. So you can spend some time and practice that. I would suggest you start with the first, you and your group should start with the sample project first. Start with the sample project. Understand one of the project first. It may take 2 hours to understand sample project. Then you go through this process and try. Don't just do the homework or project, then there is no learning. This class, this learning itself can get you a job if you know the thing concept very well. It doesn't require years of experience for data analysis. It's just your common sense. Either you associate, cluster, decision, correlation, regression, classifications, use it. And there are so many things you know about this thing. So next week we'll have a class project presentation. That's pretty much